Today I'm going to show a pneumatic exercise here in my laboratory. We have today this set of valves and actuators that are driven by air pressure. If we want to see this is a combination of valves and actuators, and this is the power unit. It contains this bulky compressor and this tank and this set of valves and gauges. This gauge, the lower one, this lower gauge, is for measuring the pressure in the tank, and the upper one for measuring the pressure that out from the compressor. This is a pressure control valve, and this is the main pressure line. Here we get the compressed air, but it's full of moisture and deposits, so we need to put this unit, so-called DFR, D dryer, F filter, R regulator. It filters the air and take all of the moisture and regulate the pressure through this valve, this pressure valve, and we know the pressure by this gauge, and this is flow control valve. So air out of this port filtered, dry, and regulated in both in pressure and flow. Then the pressurized air enter this manifold, air manifold, our dispensing unit. It has one input point and 8 outputs. In each output there is a one-way control valve. So we connect a set of valves and actuators to achieve a beautiful result. If we turn on the flow, see the pressure is equal to about 3 bar. It's quite enough for the experiment. We connect AND logic circuit. If we push both of these buttons, what we have? Let's see. And release. It's beautiful result. This is a push button Y control valve. We see the diagram for it here. It's a Y control valve, for a pneumatic system. It has 2 connecting positions and 3 ports, 1, 2, 3, normally closed. Here is another one that is normally open. Here is the valve that controls the experiment. It's called, as we see in this sheet, double pressure valve or dual pressure valve. It has two inputs and one output. Where it is, I put it there, yes. If the pressure flow through this port, it doesn't open because the plunger closes the output port. And if the air flows through this port, we have the same result. But if the flow through if the pressure flows through both of the input ports, the main plunger sit in the middle position and the air flow around it from here and here through the output port. So we do a logical and experiment. If we push both of the buttons, the exercise works. If we push one of them, it doesn't work. If we let or release both of them, we doesn't have any effect. So these two push buttons, pneumatic push buttons, control the flow to this double pressure valve. Then the air get out from this valve to this time delay valve. It has one input and one output here. We can control the time of the opening by this knob by seconds. I will put it in 5 minutes. Contains a counter, mechanical counter, that control the flow from this valve. After that, we have this violated directional valve, two positions and 5 ports. Number 10 port is the violated port. If a low pressurized air flow through this port, it would open and connect 1 and 4 ports to the actuators. Then, after that, the flow go to the one acting cylinder or a single acting cylinder, this one, flow through this port, then to the air through this port. The cylinder will move and push this valve that called a roller lever Y control valve. It has this lever. If we push it, it will connect this port, this input port, with this output port, and the flow will go to the rest of the system. I've put another time delay valve here to control the time of this single acting cylinder. I put it to have another function. Then it will move, then press this roller lever directional valve and open the flow of air to do another function. It's a pretty simple and beautiful exercise. Let's turn on the exercise and see the results. Push both of them. It works. I push one of them, don't work. I push the other, don't work. If I release both of them, don't work. If I push both of them, it works. Okay. Let's turn off the pressure. I will put another logic control valve that's called shuttle valve. Shuttle valve has the same as the first valve, the door pressure valve. It has two inputs and one output. If the pressure flow through this port, it will push this ball and open to the outlet. And if the flow through this port, we have the same result. If the pressure flow through the both of them, we have an output. But if there isn't any flow through this port, the both of them, we haven't any flow. So let's connect it and know the results. Input number 1, input number 2, input number 3. We should make sure of the tightening up of the connections because some students don't connect it firmly like this. Okay. If I push, okay, let's open the flow. Push both of them. Okay, we have output. If I pushed one of them, I have function. I push the other one. I have function. If I release both of them, I don't have any result. I put this valve that controls the flow in one way. If we see the diagram for it, here, this one. It's one-way flow control valve. If the flow or the pressure flow through this port to this port, it will go and impact with this ball. Then it will be forced to flow through this flow control valve. If the direction of the pressure contracts in the other direction, it will go through this port to this ball and push it and go out without any control of its speed. This valve controls the speed of moving of this cylinder, and this valve controls the speed of the advancing of this other single acting cylinder. This is a time delay valve. I put it on 5 seconds, the same as this valve. So it's a beautiful, useful experiment. It has a lot of applications in the industry. I hope you enjoy the experiment. Thank you very much.